Okay, this is the AP Calculus 4.5, section 4.5 lecture. A new technique for integration, and this is called integration by substitution, and we're going to be undoing the chain rule. So we've been undoing the power rule, going backwards. We're going to go backwards with the chain rule this time. So let's do a warm-up problem. And it's our warm-up problem is find dy dx if y is equal to 5x cubed plus 2x to the fourth power. Okay, so y prime, I'm going to remind you of the chain rule here. We're going to bring that 4 out front. So we have 4 times 5x cubed plus 2x, subtract 1 from the exponent, so 3. And then times the derivative of, what do we call this, the blob. Okay, so that would be times 15x squared plus 2. All right, and let's go backwards now. Let's evaluate integral 4. We're just going to evaluate this thing right here. 4 times 5x cubed plus 2x, all cubed, times 15x squared plus 2 dx. Well, we know that if we integrate that, we're just going to go back to the original function. So it would be 5x cubed plus 2x to the fourth plus c. So I'm going to refer back to that in a second. So one method for evaluating integrals involves untangling, not really a math term, the chain rule. This technique is called integration by substitution. All right, so I want you to notice that 5x cubed plus 2x, so I'm referring back to this problem up here. 5x cubed plus 2x is a part of both the derivative and the integral. And the derivative of 5x cubed plus 2x is also sitting in the problem. Okay, and of course that is 15x squared plus 2. Okay, so that's in there. That's in both the derivative and in the integral, okay? Okay, so pause the video if you need to. I'm going to erase all this. Okay, a couple of quick terms. Remember that if you see d dx, all right, that just means that's a verb. Differentiate with respect to x. Okay, an action or command. All right, so if you see an integral and then dx, okay, a function, that just means integrate. With respect to x. Okay, let's do our first substitution example. All right. We're going to integrate x times x squared plus 4 to the 20th dx. Okay, so listen close. This is what you want to do. So what we're going to do is we're going to rewrite this problem in terms of the letter U. Okay? We're going to rewrite in terms of the letter U. In fact, when I was taking calculus in college, they called it U substitution. So what you want to do is you want to pick U. So pick a U. Right? So that when you take the derivative, to use it is sitting in the problem. No, this is a run-on sentence. It is just off by a constant. Okay, let me tell you what I mean here. We're going to pick a U, all right? And the U is the same thing as the blop if you were to take the derivative, okay? So see how we're going to let U be x squared plus 4. The reason I'm picking U to be x squared plus 4 is if I take the derivative of that, it's 2x, right? Well, the 2x, x is sitting in the problem. That's almost the same as 2x. It's just off by a constant. Okay, so for this problem, we're going to let u be x squared plus 4. Then we need to take the derivative of that. Du dx is equal to 2x. So du is equal to 2x dx. Now see how du is basically sitting in the problem. There's a 2 out front. We'll fix that in a minute, but see how there's an x and a dx, x dx. So we could say 2 times du, or excuse me, not 2. Divide both sides by 2, and you'd have 1/2 du is equal to x dx. Okay, x dx is sitting in the problem, x dx. So now we're going to rewrite this entire integral in terms of u. Now I need to put a 1/2 out front because we have this 1/2. Okay, see how u is x squared plus 4. So let's write that in. U, but that's to the 20th power. So it's u to the 20th du. If we were to substitute back in, that'd be x squared plus 4. U is just x squared plus 4. We're just rewriting it in terms of u. X squared plus 4 to the 20th. And then du is x dx. We have the x and the dx right here. And then you have a 1/2 out front. All right, let's integrate u to the 20. Well, that's going to be u to the 21st. I'm going to bring that 1/2 that's right here. But we're going to need 1/21, right? Let me rewrite that. That's kind of messy. So 1/2 times 1/21 u to the 21. See, after you take the derivative of that, 21 times 1/21 is 1, and then u to the 20th. So we got a 1/2. So this is going to be 1/42 u to the 21st power plus c. You're almost done. You're almost done. All you got to do, you put u in the problem, you got to take u back out. Let me repeat that. You put u in the problem, you got to take u back out. All right, what is u? It's x squared plus 4. So the answer is going to be 1/42 times x squared plus 4. I'm substituting that back in for u to the 21st power plus c. So that is the answer to integrating this function. Now I'm going to leave that answer there. I'm about to erase all of this because I'm going to prove to you that that's the right answer. Okay, so pause the video if you need to. Okay, so if this is the integral, okay, this is the antiderivative of this, then when we take the derivative of this, we should get that, right? Okay. So the derivative of this would be 21 times 1/42, so that'd be 1/2. 21/42, x squared plus 4 to the 20th times the derivative of the block, so times 2x. What happens to the 2 and the 1/2? It goes away, so you have x squared plus 4 to the 20th. There you go. We checked it. It's the same thing. All right, this u substitution business takes some practice. I'm going to work 3 more problems for you. By the time we get to the 3rd and 4th problem, you should feel better about it. If you're confused right now, go back and watch this section once again if you need to. All right, let's try another one. So we've got 3x squared times the square root of 5 plus x cubed dx. And I want to integrate that. Okay. What you want to do is you want to pick a u. When you take the derivative of it, it's sitting out in the problem. Well, if we let u be 5 plus x cubed du. Now, in the last one, I put du over dx, and then I multiply both sides by dx. Let's skip that part and just go ahead and put it as in terms of dx. So, what's the derivative of this? 3x squared dx. See how 3x squared dx is sitting right in the problem? So now let's rewrite that integral in terms of u. Well, it's going to be the square root of u, because u is 5 plus x cubed, but we got to do the square root of it. And then 3x squared dx is du. See how we simplified that thing? That thing's nasty looking. We simplified it just to that. Well, that's the same as u to the 1/2 du. Let's integrate that. You can do it. U to the 3/2, but we need we need a 2/3 out front. And then that would be plus c. So I didn't have to put a constant or anything out here because we had that. I didn't have to make it 1/3 like I did on the last one because 3x squared was already sitting there. All right, don't circle that. You put u in the problem, you got to take u back out. All right, so it's going to be 2/3. What is u? It's 5 plus x cubed. To the 3/2 plus c. Could we check? Could we check? Could we check? Could we check? Yes. How do you check? Take the derivative. 3/2 times 2/3 would be 1. So it's going to be 5 plus x cubed to the 1/2 power times the derivative of the block 3x squared. There you go. So you checked it. It worked. All right. 2 more examples. All right. This example comes from the book. It's example 2 on page 296. So it says evaluate x squared times the square root of x cubed plus 1 dx. All right, you tell me, what do you think u is? All right, pause the video, take a guess. What do you think u is? All right, u is going to be x cubed plus 1. Because if I take the derivative of that, it's 3x squared, which is almost x squared. It's just off by a constant. Du is 3x squared dx, but I don't need 3x squared. I need x squared dx. So divide both sides by 3, and you'd have 1/3 du is equal to x squared dx. So let's rewrite an integral, a simplified integral in terms of u. Well, it's going to be the square root of u, because u is x cubed plus 1, square root of u. X squared dx is du, so square root of u du. All right, let's evaluate that. So that's going to be, we don't want to forget about that 1/3 out front. Okay, and this is u to the 1/2, right? I'll rewrite it again. Okay, so that's going to be u to the 3/2. It's very hard to see that 3/2. You get a little smudgy. But I need a 2/3 out front. 3/2 times 2/3 would be 1, and then subtract 1 to 3/2. But we got to multiply by the 1/3. So that's 2/9 u to the 3/2 plus c. You put u in the problem, you got to take u back out. 2/9. What is u? It's x cubed plus 1 to the 3/2 plus the constant of integration. Could you check? Could you check? Could you check? Yes, I will let you check. I'm going to tell you it checks. All right, I hope you're feeling better about all this now. Let's do one more, one that's a little bit fancy, but not too bad. This is example 16. Page 296. So we have to evaluate x squared over 16 minus x cubed squared dx. Okay, what do you think u is going to be? Take a guess. All right, u is going to be 16 minus x cubed. Why did I pick that? Because when I take the derivative, I have a version, it's minus 3x squared, but I have a version of x squared dx. So du is equal to minus 3x squared dx. I don't want minus 3 though. I just want x squared dx. So let's divide both sides by negative 3. So negative 1/3 du is equal to x squared dx. Now I can rewrite this integral in terms of u, a simplified version. X squared dx is du. And then we have on the bottom u squared. All right, u is 16 minus x cubed and then squared. Well, that's the same as negative 1/3. And then we have an integral u to the minus 2 du. All right, that's negative 1/3. And then you have u, add 1, so minus 1, but I need a negative out front, right? Negative 1 times negative be a positive, then u to the minus 2. So that would be negative negative makes a positive, so that'd be 1 over 3u plus c. Are you going to circle? Are you going to circle? Are you going to circle? No. You put u in the problem, you got to take u back out. 1 over, practice saying that real fast, Wilkerson. 3. What is u? 16 minus x cubed. Plus c. Can you check? Can you check? Can you check? Can you check? You can always check. Give it a try. It checks, I promise. You take the derivative of that, it's going to equal this. Okay, let me write down the homework. Pause video if you need to. Okay, the homework. It's on page 296. 1 through 19 odd. And also number 27. All right, I haven't looked at those. If I have any, if there are any issues from the answers in the back of the book, or you need special instructions, I will post those on the Microsoft Teams post area for you. And that does it for this video, and I'll talk to you next time.